All right, so a probability experiment is essentially the entire event that you're doing, that you're trying to get some results. And then the outcomes are the individual results that you get are each called outcomes. Okay. So now the first one that we're going to talk about, we have a pair of dice that we're going to throw. And the sample space is made up of all the possible results of throwing 2 dice. You can throw die 1 and get a 1, 2, 3, 4, 5, or 6 on it. You can throw die 2 and get the same set of choices. If you want to look at 2 of them together, then our results are 1, 1, 1, 2, 1, 3, 1, 4. So the first number of the ordered pair would come from die 1, and the second number would come from die 2. So this is a sample space for the set of all possible outcomes of a probability experiment. So your question might be, what are the possible outcomes, or what's the probability of getting a sum of 6 when you toss 2 dice? So a sum of 6 could come from 3 and 3, or it can come from 4 and 2, or it could be 1 and 5, but of course it could also be 5 and 1, 5, 1, and 1, 5. And so the sample space is how you look at your results in order to answer questions about the probabilities. A tree diagram is another way that we can combine these, and especially if we have several different events going on. So the tree diagram is just line segments coming from a starting point and then going out to an outcome point. And you use it to determine all the possible outcomes of a probability experiment. A real common one to do this on is the possible arrangement of child genders. So we can have 3 children. The first child can be a boy or a girl. The second child can be a boy or a girl. So we had a boy, then we can have a boy or a girl the second time. If we had a girl, we have a boy or a girl the second time. And in the end, we end up with having 8 different outcomes coming out from each node of the tree diagram. So these are the branches, and finally out here at the end you have the leaves. So from a leaf, you can look backwards and see that this is boy, boy, boy. This is boy, girl, a boy, boy, girl. Boy, girl, boy, boy, girl, girl, and so on. And so then you can see visually all the different possibilities of that particular experiment. So 3 children, and what are the arrangements of the genders? Now an event is one certain set of outcomes of the probability experiment. So like I said just a second ago, the tree diagram with the boys and girls, well, an event might be 3 boys. An event might be 2 boys and a girl. If we had 2 boys and a girl, then perhaps the 2 boys are first. The 2 boys might be first and last. The 2 boys might be second and third. So we can have 3 of these events satisfy the requirement, 3 of these outcomes fit into the event of 2 boys and a girl. And that's the sort of question you're going to be looking at for the majority of our probabilities. An event with 1 outcome is called a simple event. And an event with more than 1 outcome is called a not simple event. It's really brilliant, let me tell you. Okay? Now there's 3 types of probability. There's classical probability, which uses a formula and the basic nature of your event. Of your experiment. For example, the probability of tossing a heads on a fair coin. Well, that's 1 out of 2 because of the nature of the coin, not because I did any experiments. Empirical is where you take the actual results of some experience or experiments and to determine the likelihood of your outcomes. So classical is just from the nature of your probability experiment. Empirical is from actually performing your experiment and getting some experimental results. And then there's subjective. Subjective doesn't really fit into statistics. Subjective is just an educated guess. And it's an estimate where you just employ opinions and inexact information. In general, we don't really bother with subjective probability very much, because the sorts of things that we want to do are real heavy on calculations, and we'll want to stick with classical or empirical. Well, we got some rules we got to learn. Okay, the first one is called probability rule number 1. is that the probability of an event is a number, which can be written as either a fraction or a decimal, between and including 0 and 1. So it's from 0 is less than or equal to the probability of our event, which in turn is less than or equal to 1. So we read this as the probability is between 0 and 1, inclusive. So if an event cannot occur, then its probability is 0. Okay? If an event cannot occur, just cannot happen, then its probability is 0. Can anybody come up with an event with a probability of 0? Just type it into the chat window here. Just come up with an event whose probability is 0. Come on, I see somebody typing. It's not that hard. An event where the probability would be 0. Something that cannot happen. A black cat cannot be a white cat. Okay, that's good. That's good. Okay? Come Halloween, it might want to be a white cat, but we won't talk about that. Okay, a man has a baby. These days, not so sure, but that's all right. If an event is certain, then the probability of your event is 1. So all your probabilities are going to go from 0 to 1, where 0 is can't happen, 1 is must happen. And then the sum of all the probabilities of all the outcomes, if you've got several different outcomes in your sample space, they all have to add up to 1. And that's pretty important, that your sum of your outcomes would be 1. Because as a matter of fact, a lot of statistics is built on that concept. The complement is the set of outcomes that are not included in the outcomes of your event. So it's essentially the opposite of your event, okay? The complement is essentially the opposite, okay? All right, addition rules. I'm just going to spin through a few rules for you, and then we'll apply them. The addition rules. If your events are mutually exclusive, and can somebody put in an example of what is mutually exclusive? What does mutually exclusive mean? Okay. Does nobody know what mutually exclusive is? Okay, Tim, thank you. I have 2 people willing to actually respond. This is good. One event outcome does not affect the other. No, that would be independent. Okay, mutually exclusive. I'm going to let Darlene finish typing. Well, nope, you both have come up with the definition for independent. Mutually exclusive means if one happens, the other cannot. So an example of that might be, if it is Friday, then it cannot be Saturday. So Friday and Saturday are mutually exclusive. So 2 things that are the same type of category and the same type of measurement, generally you can have one but not the other. Those would be mutually exclusive things. But things where that could overlap would be not mutually exclusive. So if your events are mutually exclusive, then your probability that either one or the other is to simply add the 2 individual probabilities together. Okay, so the word or generally means plus. Okay, the word or generally means plus. If A and B are not mutually exclusive, then you have to worry about the intersection of the 2 events. So in that case, it would be the probability of the first one plus the probability of the second one minus the overlap, because the overlap is going to get counted twice. So let's look at a picture. Here we have mutually exclusive events. So if A is completely separate from B, then the probability of A or B is simply A plus B. However, if they're not mutually exclusive, then that means they might overlap. So then we would have the probability of A plus the probability of B, but you notice that that middle section has been counted in both categories. It was an A, but it was also B. So it's A plus B minus the probability of A and B. So and means both at the same time, has to be both of them together, or means at least one. Or actually could be both, but and means that it has to be both. So in summary, when the two events are mutually exclusive, use addition rule 1. If the events are not mutually exclusive, you'll use addition rule 2.